Hello, my name is Andy Lazur. I'm a water quality specialist with the University of Maryland Extension. And topic of today's webinar is basics of pond management. So in this 30-minute webinar, I will cover a couple of items, some of the basics of pond ecology, some challenges and problems that we often see with ponds, and then talk about some of the management, some of the strategies and practices that you can employ to maintain a healthier pond environment. So there's lots of different types of ponds and they're used for lots of different things: recreation, fish production, stormwater management or sediment control. There's irrigation, firefighting, etc. And it's important to understand that a pond is an ecosystem. And part of that ecosystem is the pond's watershed, or the land area that drains into that pond. And so that drainage will impact the water quality of the pond, as well as the pond bottom. The soil also will impact or affect the water quality. And so in typical ponds, we're very concerned about nutrients, primarily nitrogen and phosphorus, but along with watershed, dependent upon the various land uses and proximity to roads or whatever, you can also get different types of pollutants, oils, things like that, for example, salt from road salts. And so looking at pond water quality, there's a particular list of parameters here that are important and do impact the quality of the habitat in a pond. Temperature, certainly. There's a lot more biological activity in the warmer months, and then obviously during the winter months, things slow down. pH, ammonia, nitrite and nitrate, phosphorus, dissolved oxygen, of course, and then there's carbon dioxide and alkalinity. And I'll touch a little bit on a few of these. So again, think of a pond as its own ecosystem. And what we have going on in a pond is a lot of nutrient cycling, a lot of different types of aquatic life. For example, we have phytoplankton here, or microscopic algae. It's a green plant. Then we have shoreline plants, for example. We might have some other plants, might have some rooted plants like lilies and things like that. And those plants are taking advantage of nutrients and sunlight in order to grow. And these plants, and particularly the phytoplankton, is continuously growing, and it dies off. And when plant material dies off, or when you get in the fall, you get leaf litter coming in here, you're adding organic matter down towards the sediment. If you have geese, for example, they're adding a lot of nutrients, and that organic matter will settle down on the bottom, and the bacteria, beneficial bacteria in the pond, will start feeding on that organic matter. And as they do, they give off carbon dioxide. They need oxygen to do that. They may give off other gases as well. Some sediments, if it's a thick layer of organic sediments and it tends to be anaerobic or without oxygen, you might actually get some hydrogen sulfide production. You might get some nitrogen gas as that nitrate is converted to nitrogen gas and then vents off out into the atmosphere. So again, there's a lot of cycling that goes on. And typically, some of the biggest problems that we see with ponds is excessive nutrients, whatever they may be. Runoff from fertilizers, or a lot of wildlife, and in particular geese, because you're getting feces from the geese, not only in the water, but certainly on the adjacent land area. So a little bit on water quality, particularly with oxygen. Those aquatic plants that I just described, again, they are producing oxygen during the day, during the sunlight hours. And so you're naturally going to see a increase in oxygen concentrations. But then during the evening hours and nighttime hours, those plants are also consuming oxygen. The bacteria is consuming oxygen. And so those, you get this diurnal cycle here. So the greatest or the highest oxygen levels tend to be in the afternoon, early evening hours, and the lowest is generally early in the morning. You can modify that cycle in the degree of this curve here by adding aeration, for example. And aeration can be used at different types of strategies, put on a timer and operated during the nighttime hours to try to reduce that dip, if you will. It's also important to note that sunlight is really critical to that oxygen production. And so when you have a situation here in bright sunlight, you're getting that nice peak, high concentrations of oxygen, but then you start having a couple of cloudy days and it'll drop off. It won't get as high in the afternoon, but that respiration rate is still happening. And sometimes you run into situations where you can get a low dissolved oxygen situation in early morning hours, particularly in the summer months. Now, in addition to oxygen cycling daily, pH cycles too. Most people aren't aware of that, but again, because of that photosynthetic respiratory activity, you get pH cycling as well. And so it tends to be lowest in the early morning hours and highest in the afternoon. In this particular example, pH is going from say 5.5 up to say 10.5. That tends to happen when you have water of low alkalinity. And alkalinity is basically just the measure of the bases, the carbonate bases in the water, and it buffers the pH. So if you have low alkalinity water, you're going to get a higher peak. If you have high or moderate alkalinity, it buffers that pH swing. So a lot of dynamics going on there, biochemical activity that influences the water quality. Now, aquatic plants are an important feature in ponds, and they provide a lot of benefits. I mentioned already oxygen production. They take up nutrients, certainly, but they also, dependent upon the species, can help even reduce the turbidity. They provide habitat, and they're good, particularly on the shoreline or the shallow areas, for erosion control. Now, again, too much of anything can be bad, if you will, and you get a lot of oxygen consumption. Some types of aquatic plants could be considered more of a weed. They become unsightly. For example, some of the algal scums or the filamentous algae, duckweed covering an entire pond. Certain types of algae gives off flavor, for example, kind of a musty or muddy smell or even a taste in the fish. As some of that algae dies off, it can create some odor problems, and certainly interferes with the uses that we talked about if you're trying to fish or swim, things like that. And then we have different types of aquatic plants. We have floating, like the duckweed, for example. We have the algae that I've already talked about. We have submerged species of plants, and these are rooted in the bottom. We have emergent species, and then marginal. These are the shoreline types of plants here, example of cattail. So this is algae. This is the green color that I was describing to you. This is a phytoplankton, what we call a bloom or population. Here's a situation where we have filamentous algae, and you can see the degree of coverage. And so if this looks like a diving platform or a fishing dock, and certainly that filamentous algae interferes with those use. But algae is very common, obviously different types. Certain types of blue-greens, for example, can create odors. We have the filamentous kind that you can see on the bottom right, as I mentioned, and it can get pretty thick. And again, they produce a lot of oxygen, but they also consume oxygen. And we have our floating plants. Example is water hyacinth, which is an invasive species, and duckweed, you can see here on the bottom. Duckweed here is covering up a large portion of the pond. Oftentimes the wind, if you have a small pond, the wind will blow this to one edge, and sometimes you can actually scoop it up. It's subject to moving around with wind action. And again, they are excellent at utilizing nutrients. If there's nutrients coming in off that watershed into the pond, these species can be fairly aggressive. Now, submerged plants, some of the common ones are hydrilla, again, an invasive species. There's coontail and elodea, for example. And again, a certain population of native plants is a good thing. It's just when it gets out of control due to excessive nutrients that it can become a nuisance or interfere with the use. Again, these are rooted. They take up the nutrients. In shallow areas, this can be a problem, particularly where sunlight's able to penetrate to the bottom. And these plants, again, if the nutrients are there and they have the sunlight there, they can get pretty thick in coverage. And again, you have the marginal plants. An example was earlier was the cattail. In this case, there's Phragmites here on the bottom. And it's, again, can be pretty invasive and cover up the whole perimeter of the pond. And over time, cattail and Phragmites, they produce a lot of organic matter, and then that dies off and accumulates around the edge. I've seen ponds that have been choked with cattails, for example, that, eventually, you reduced more than 50% of the pond area because of all this, annual dying, growing and dying of material. Again, their rooted tends to be in the shallow areas, and they spread very quickly through rhizomes. So looking at Maryland specifically, these are the typical species that we have the most calls about and trying to, offer some sort of control. And again, oftentimes this is because it interferes with the desired use, swimming or other types of recreation, fishing, whatever the case may be. You've seen some of these here before. So when we look at control, just like so many things, prevention is the best way. And the biggest thing there is reducing nutrient inputs. If you reduce and limit the food, if you will, the nutrients to the plants, obviously you're minimizing the potential for excessive plant growth. And then actually you can use beneficial plants in certain settings, in certain species, to use up nitrogen and phosphorus that would not go to, say, some other nuisance species like Filamentous algae, for example. So that's certainly the key strategy. There's mechanical removal, but that's, again, very labor intensive and not feasible if you have a large pond, certainly. We don't really have any biological control organisms that are permitted in Maryland. Other states are allowed to use certain types of fish species. We're not here. And then the other alternative control method is chemical herbicides. So here's some typical situations that we have seen and worked with over the years. Here we have a stormwater pond that is pretty heavily infested around the perimeter, the shallow edges on cattail, for example, maybe a little bit of Phragmites mixed in there. The case where you're trying to have some recreational value, maybe even a walking trail around the perimeter of a pond or through the neighborhood, and maybe you have a bench that people can sit down. They're not going to be able to see over the cattails and enjoy the pond. And so a lot of these ponds will sometimes have a sort of water feature to add aesthetic value. And so if you have a lot of Phragmites or cattail, it's very difficult to utilize that pond. Here's an algae scum situation. You can see different types of colors. You can actually see where some of these mats are turning brown and dying off. This particular situation was giving off an odor. Here's some filamentous situation. You can see this is in the shallow part of a pond. And again, it's natural to have, algae of some type. It's just when it gets excessive that it becomes a problem. Phytoplankton, or you have a lot of other types of vegetation that dies off, it can actually create fish kills. Now, stormwater ponds, and there's literally thousands, tens of thousands of stormwater ponds in Maryland alone, and there are issues with stormwater ponds. They do a great job, or can do a great job in trapping sediments, and that's their primary purpose, is to trap sediments as well as nutrients, because a lot of that phosphorus gets bound up in the sediment, and these ponds can, and they're designed to trap sediments. But yet we can get problems. Here we have a case where we get a lot of filamentous and other types of vegetation filling up the pond, creating some odor issues, things like that. Geese, again, are a beautiful wildlife species, but they add a lot of nutrients to a pond environment, and in some cases, people will feed them, and that's just encouraging them to stay there year round, adding nutrients continuously. So what happens in a lot of these ponds that trap sediments? They're trapping up organic matter from upstream. Then you have different types of plants around the edge, if you have a lot of filamentous algae, again, as I said earlier, that's going to die off, fall to the bottom, can fill in, maybe not completely, but they may be designed originally to have 6 feet of depth, but then they can, over time can, that can become much less. And you get this thick organic matter building up, and it's constantly releasing nitrogen and phosphorus to feed the algae or other unwanted species. And then the bottom right here is showing a new development where they have a 2-stage stormwater pond. In this case, this first part here, water's coming up from upstream here into this what's called a forebay, and you can actually see the difference in color. This forebay is designed to take the bulk of sediment load before it goes into the larger stormwater pond. And again, it's doing its job. And so it depended upon the development and how long it takes for all the houses to be developed, and then also vegetation to reduce the amount of sediment. This is a smaller area to remove sediment if you had to do that. So here's a publication that we have that's available specifically on stormwater ponds, mentioning some strategies. There you can see the URL. And the idea here was, this was based on some work that we did in conjunction with communities and a plant producer, looking at using beneficial plants to help reduce the amount of nutrients going into filamentous algae or some of the algal scum situations that they were having. And that publication has a really nice comprehensive list of desirable native species that can be used, describes some of the features that are available, some of the wildlife habitat, do they flower, or when do they flower? Again, trying to encourage an aesthetically pleasing pond. And so these beneficial plants can offer that. This is just one of, I think, 3 or 4 pages of desirable species to consider. And then again, this whole idea of using beneficial plants to remediate nutrients is really important. And so what you see here is, this is actually an example of agriculture here, where they're using what's called riparian buffers. So anything around a water body, you can see vegetation. This could be various grasses that are planted. You certainly have trees around this series or this creek here. And that's proven to take up excessive nitrogen and even sediment, trap the sediment before it gets into those bodies of water. So here's some examples. Here is a pond buffer looking at different pollinators along a portion of the edge. This particular pond looks like it has an opening here, maybe for fishing to occur, whatever the case may be. So it gives you a sense. Again, the idea here is to trap the nutrients that are running off from the landscape, from the turf, trap them. These plants are utilizing those nutrients before it gets into the pond. And another strategy that's used is what's called a floating wetland. And so you're actually have plants growing on a raft system, and there's different companies that make different types of systems. And you put plants in here, and the plant roots are directly in the water, helping to take up nutrients. It's shown to work. And again, it's just one strategy in combination, because this particular pond, they're also using shoreline plantings as well as a means of trying to reduce that nutrient runoff going into unwanted vegetation. And I encourage you to consider, this is our Baywise program. They actually have what's called a yardstick. And it's all about educating landowners on how to maintain not only the landscape, but how to be better stewards. They talk about turf fertilization is obviously one of the big things to do to try to reduce the amount of nutrient runoff and sediment runoff into bodies of water. So here's a list of basic practices to consider in pond management. It's really important to kind of know your watershed. What's on your watershed? How big is your watershed? What's flowing in? How many homes, if you're on a community pond, how many homes are there? Again, emphasized, this is the big take-home message here: reduce nutrient inputs, whether that be turf fertilizer, garden fertilizer. Don't encourage, don't feed geese, those types of things. These beneficial plants. It's also important to even know a little bit about your water quality, particularly alkalinity, for example. And this is important if you do have to use a copper-based herbicide. Copper can be toxic to fish at low alkalinity. So it's important to kind of know that. Again, do not feed the wildlife and the geese. If it is a fish production pond, then it's a different situation. You're going to be feeding that pond, but you're also know when you start adding feed to grow fish, you're going to get a lot of potential phytoplankton growth. And so you need to understand that. And then if you do have any sort of aquatic weed issue, you definitely need to identify it or have it identified to determine what your options are. And there's a great resource, probably the most comprehensive in the nation, called Aquatic Plants. It's out of Texas A&M University. There's the link there. It can help you identify the species of plant, talk about the control methods. Another key point about maintaining a good healthy pond is do not introduce wild fish. If you have your pond stocked, leave it that way. Go back if you need to restock, but don't introduce wild fish, and obviously don't overstock your fish. I mentioned a little bit about water gardening because I get questions on this, and certainly water gardens are a small pond. The big difference here with a water garden is typically they have a plastic liner, and therefore you don't have that soil water interaction, because the pond soil is also providing habitat and a means to help cycle or break down some of those nutrients. So with a liner, you don't have that, and actually can influence the chemistry of the water itself. But certainly the big thing with water gardens is to try to put it out away from trees, so you're not adding all that leaf litter, because that's a lot of work to try to scoop out leaves, and you don't want leaf accumulation over time, because it's, again, adding a lot of organic matter and fertilizing filamentous algae or whatever that most people don't want. They want a clear color water, less turbidity, so they can see their fish, for example. And it's nice to have it where you can partially drain it, or sump areas that you can help remove any solids over time. Plenty of plants, as you can see in this picture here, to help take up nutrients, because again, these fish are fed on a daily basis. This particular pond has a biofilter as well to remediate some of that nitrogen waste from the food. Mechanical aeration, whether it be a fountain or some sort of bubbler system, is important. And again, as with any type of other pond, do not introduce wild fish and do not overfeed. So recreational fishing is often an important end use for a pond, and can provide a lot of recreation and opportunities for a community. And so here's some just general information. Again, that Aquatic Plants Texas A&M link has some information on that. So it just kind of gives you some information about what can produce. Oftentimes people think that they can produce a lot of fish in a pond, and if you're using it for multiple purposes, chances are that you are not going to be able to produce a lot of fish in a pond unless you're specifically managing it for that. And so this gives you kind of an idea of what you could harvest on an acre basis. If it's a managed pond, you might get 25 pounds of bass and maybe 100 or 200 pounds of bluegill, for example. So I'll end with I think a wealth of information, resources available. Here's the Maryland Department of Agriculture pesticide licensing and certification site. And right here, you can see, I printed off here, this is the aquatic license. So if you had some algae or aquatic plant issues that you wanted to hire somebody, there's a list that you can go to this website and actually search under businesses. This is this particular search looked at certified pesticide businesses under the aquatic. Here's some information on the DNR fish stocking. They have a program that they help private landowners fish stocking, for example. And then this is another excellent website on how do you control resident geese, and provides a lot of wealth of information there. The big thing with any sort of waterfowl type of control is you've got to be dedicated and follow through to whatever methods that you use. And again, this site describes the various methods that can be legally used to try to control geese. And then lastly, here's just, again, some other resources. There's my email address. And then there's a stormwater manual. If you're interested there's a great resource from MDE on that. Repeat of the Aqua Plant. And then Maryland Sea Grant has a publication and some information on pond management as well. So I've enjoyed the opportunity to share some information with you. And please contact me or these resources that I provided to you if you need additional information. Thank you.